there'll be a page, there'll be instructions that tells you what different things you need to touch upon. So before you start a proposal, you should be reading all of these pages and instructions to figure out what it is you need to, what requirements you have to meet in order to make the proposal. Okay, so a little bit about proposal writing. And so I am currently in the middle of writing a very, very large proposal. In the US, we have a new mission concept that's called a probe class. It's for a $1 billion mission. So this is very high. This is a very big proposal. And as part of that, I got exposed to a lot of storytelling and story writing exercises from JPL, which is who we write it together with. And I wanted to share a little bit of that with you because I think it's useful, even though this is geared towards a huge proposal, the same principles actually work for small proposals, and they're useful to keep in mind. So let me just go a little bit through that. So there are goals versus objective. So a goal is typically a very high level question. It is something that your proposal is trying to, it's taking a step towards the overall goal, but it is not going to solve that goal. The goal is sort of an ongoing thing. And here's a couple of examples going from very large and big to kind of the smaller, which you would have in your own proposal. So here's a couple of examples. So JPL is basic as mostly a planetary center. So this is why you see this planetary, which is ascertain the origin and evolution of the solar system and to understand the potential for life beyond Earth. You can see that's an enormous goal. If you wrote one proposal to solve that, you would get a Nobel Prize. You're not going to do that. So the objective is then you're going to take one step along that path towards the goal. And so the answering of that to this top question with the planetary one is to determine if life exists in this Martian latitude and longitude within the top 5 centimeters of the surface. It's a very specific objective. It's very, very, very specific as opposed to the goal, which is very overarching. And the next one is an example from my proposal is understand the black hole's growth over cosmic timescales. You'll see that sentence many times in different contexts. It's a very common sentence, very common goal. So for this, you could have the objective would be measure the spin of supermassive black holes out to a redshift of 1. Actually, I would say this might not even be objective enough because I might say I need 20, very specific, I need 20 supermassive black holes out to a redshift of 1 to answer one step along this. And then a much smaller kind of goal and objective, which is more in line with what you might want to do in a proposal. This is a case of a supernova remnant called Kepler. You could have the goal be understand the explosion mechanism of Kepler. And then your little objective would be, I want to measure if there is titanium-44 in the remnant and find its distribution. So there are science questions. So when you come up with a science question, there is sort of a circular thing to it. So first there is an observation. Something has gone before that triggers your curiosity about this particular physics that's going on. So it could either be something that's a known phenomena that's been seen. For example, let's say there's an X-ray binary has a type 1 burst. And you want to know, is type 1 bursts common for other types of X-ray binaries? So it can be based on a known phenomena or a theory. And then you have to articulate a science question to go with it. Then you have to do what's called a hypothesis. So we can see so let's say there's another X-ray binary type, which are called, let's say, do all low mass X-ray binaries have type 1 bursts, for example? That's a hypothesis. And then you have to do a prediction. What can you measure to tell whether it's there or not? So then your objective would be, is there type 1 X-ray bursts in, for example, a set of XRBs, low mass X-ray binaries that you have picked? You've picked a list of them, 10, let's say 10. And then your objective would be, is there type 1 X-ray bursts in these 10 XRBs? And then you have to do the measurement. Okay, so a little bit about science questions must be hypothesis driven. So you have to avoid when you put forth your question, you have to really, it has to be understood by everyone. It can't just be someone who is very familiar with your particular science. And this is why I left up the planetary example, because none of us are planetary scientists, but if you read that particular sentence, you will actually understand what they mean. It makes sense to you, even though you're not part of the planetary society. So for example, you should only have one question. You're just answering one question. You have too many questions, it gets confused. So in this case, for example, which has too many questions, what governed the accretion, supply of water, chemistry and internal differentiation of the inner planets and the evolution of their atmosphere, and what did bombardment by large projectiles play? It's very long. It's a little hard to understand. So the much simpler and better way to say that particular thing is, what role does cometary water and planetary impacts play in evolution of interplanetary atmospheres? So need to work on your question to make it simple and understood by everyone. That immediately, you know, if you kept this sentence, you might have to read it 3-4 times in order to understand it. Whereas you read this and it just immediately made sense. Okay, so here is this hypothesis prediction example. So you have a science goal. And again, this is again the planetary one. So understand the evolution of the Pluto system. Then your science question is, what is the origin of Pluto's moons? So the first science goal is understand the evolution of the Pluto system. It's a very large goal. You're just solving one little piece of it with the science question, which is, what is the origin of Pluto's moons? And then there's a couple of different hypotheses. The moons could be captured by Kuiper belt objects. The moons could be co-accreted. The moons could be resulted from large impacts with Pluto. The moons could have been captured by a Centaur asteroid. And then there are predictions that go with that. These are observations that could be done to distinguish between these hypotheses. So your objective then is to find the measurement that can answer this question or can distinguish between these hypotheses. So the objective would be determine the origin of Pluto's moons by measuring their surface composition. That's a blank page, even though it doesn't look blank on my thing. Oh, here it comes. Okay, so there's a couple of do's, and I didn't realize this actually had things going on for it. Okay, so there's a couple of do or don'ts in objectives, and one of them, and this is very, you'll do this, and I do it myself too. Don't state objectives to quantify, to assess. We do this all the time. To characterize, to place limits on. They're very vague, as you can see. To survey, survey is actually more of a method. Surveying is a specific method more than it's a like measurement. So those are very vague things to say. It's better to go the objective as determine if, and then you have your hypothesis to distinguish between A and B, to discriminate between. And if you can replace the verb in your objective with measure without changing its meaning, then you don't have a hypothesis based on a science objective. You can try that yourself and it actually is true. So very sad. Now, this is again, very high level. This is for $1 billion and you have to be really precise and they'll go for it. You don't have to be it's okay to go to understand, to characterize in small proposals, but do try to train your mind a little bit towards not using those words. Okay, so then there's the art of storytelling. You have to sell your idea. And if it's too dry, you might not catch the reader's imagination. It's just like when you're reading a novel. And when you read a novel, you know, when you first pick up a novel and you open the first page, if that does not hook you, and if that does not capture your interest and you put the book away, you've kind of failed. And the same thing happens a bit with a proposal. We are forced to read your proposal, but I can guarantee you, if you did not capture my imagination or my interest, not imagination, but probably interest in the first half page, if I had to reread that twice or I didn't know what it was about, I'm probably have half my mind on something else, like the cats are screaming in the background for food, you know, oh, I have to do this work, and I'll keep reading, but I'll not really read the rest of your proposal in good detail. So it's very important that you have that hook. It's a literary technique. And so it's very important that the very first page, don't keep the reader in suspense. I've seen this before. I call these mystery proposals. They're mystery writers. They don't tell you they kind of keep it too high level, and they lead you around, and you're one page down before you actually realize what it is they want to do. Do not do that. Just from the very beginning, make it clear what it is that we are dealing with, so that they know when they keep reading that they can keep that in mind. Also, don't bombard them with irrelevant details and numbers. If you have too many irrelevant details and numbers in the beginning, you're also slowing their reading down. Numbers slow down reading, especially if they've got coefficients and physical units on them. It just slows people's reading down. You want to, in the first page, you want to keep that as smooth as possible and keep it simple. Okay, the other thing is, when you write, who's your audience? You know, it's who's going to read it. Is it X-ray scientists in the same field as you? If you're doing X-ray binaries, is it going to be an X-ray binary? Is it an X-ray scientist from different fields? Is this a supernova cluster person who's going to read it? Is it non-experts from outside the field who's going to be reading it? So you have to kind of keep that a little bit in mind. And what are they going to do with it? So when it comes to proposals, you know, observatory proposals, well, let's go with abstracts first. When you write an abstract, you can be 100% sure that the person who reads your abstract is not necessarily an expert, and they're not necessarily an X-ray scientist. So you have to keep abstracts really, really top level and really simple. Well, actually, there are examples for that which I will talk about. But keep in mind, your audience, when there are proposals for a specific observatory, the people who put together the time allocation committee, they are picking people who have a specialty in the field, and they try to put people who have specialties in your particular where your proposal gets read. But that's not always a guarantee. You can have people whose it's like their secondary science. It's not their primary science, which means they know a bit about it, but they don't know everything about it. So you can never assume that you have an expert on the same level as you reading your proposal. So just a little bit about storytelling. You know, you have to kind of balance visual aids with text, with very precise text about what it is you want to do, together with some communication. You have to sweet talk them and make them interested in what you have. So it's actually pretty challenging to do this well. And it takes exercise. But once you've read a bad proposal versus a good proposal, you can really tell that there is a difference. Okay, so you have a narrative. You have to convey your idea. You have to convey what it is you want to do. So there's a layout of the narrative. So open with your science goal and explain why that is important. Why should I care about the science goal? So one of them is understand black hole growth and its impact on its host galaxy. So you can start out with that. It's a very good starting, and explain why that is really important. Why should you care about that? And then you should segue into your the science questions. How do, for example, black holes acquire their spin? Then you have a set of hypotheses and predictions, which you can then go through. Here in this case, low spin could be merger driven. High spins could mean that you acquire spin through sorry, I did mergers through accretion. This should have read accretion. Finish with the objective, you know, what you want to do. Okay, in order to answer this question, I need to do this. Okay, so a little bit about conference abstracts. So conference abstracts, there are different sizes of conferences. You can have a workshop that is sort of like this. Typically, you've got 40 to 100 people in a workshop like that. When you go to a workshop, you're almost guaranteed to have a talk. There's a pretty good chance you'll get a talk. So for a workshop, you may not have to be quite as Number one, at a workshop, it tends to be people who are in the same field as you. It's a very specific topic. So those people will be very interested in details in your abstract. So in that case, if you're at a workshop, you can put details into your abstracts. Science topical meeting, they're larger, they're 100 to 200 people typically. There, your chances are dropping to actually get a talk. And here you may, at this point, you may really try to, don't put too much detail. Already, the science organizing committee is going to be reading a lot of abstracts. So you don't want to overwhelm them with too much detail. Then there is sort of like divisional meetings. I have one example here, which is the high energy astrophysics division meeting in the US, typically 200 to 500. I'm sure ESA has an equivalent meeting for a head in Europe. X-ray universe. So it's about X-rays. It's X-ray centric, but it broadens the whole. It's a broad topic about all from X-ray clusters to X-ray binaries and to everything. And then you've got social meetings, societal meetings, which is like the AAS, which is the American Astronomical Society, COSPAR, the IAU. These are 1,000 people above. And here, it's actually interesting. The divisional meetings, I would claim, are the ones the hardest to get a talk to. It is very competitive. There'll be 100 out of 100 abstracts. They'll pick 12. So the chances of getting abstract there is getting a talk there is quite low. So you have to be really precise, and you have to be really you have to be very simple and be sure that your idea comes across very clearly in those. Don't too many details, because the person will be reading 100 abstracts and they have to make a decision on 12. And you can't remember 100. As you read through, there'll be some that stand out to you, and then there'll be others that just don't capture them. Societal meetings are a little bit easier to get abstracts to, again, because at that point they have a lot of parallel meetings, so that becomes a little more easier. So there's a science organizing committee that's gonna pick your abstracts. They may not be specialists. They may or may not be specialists in your field, but I already talked about that. And you also have to think about when the person who selects the abstracts, they try to select interesting and varying. So they want to have different types. So if your abstract doesn't get picked, don't be discouraged. It just might not be, well, you might not have captured their imagination, but you might also be reason that they wanted something else. So your abstract layout it has to be short, 5 to 8 sentences. One paragraph, don't do multiple paragraphs. If you've done that, it's too long. You're not gonna capture everything that's in there or remember it. So you basically have 1 to 2 sentences to introduce your topic. You have 2 sentences or something like that to talk about the objective and the problem, and then you have 1 to 2 to say what are the resultant findings that you want to give. So here's a bad example. Yeah, and unless you're at a workshop, do not copy an abstract from a paper. This is pretty much an abstract from a paper that was thrown in. And just trying to read through that, there are tons of numbers. It has a lot of detail, and it is great as a paper abstract. It is terrible as an abstract for a talk. By the time I've read through this, I've already forgotten what's in the beginning of it. Here's a better one, which actually comes from Javier. This abstract was picked 5 years ago for the Monterey meeting. It's much shorter. You can read these on your own, what makes them, and you can kind of reflect on that. So this was an abstract that was actually picked. So you have something like 6 to 8 sentences, 1 paragraph. Okay, so now let's move on to proposals. So here's just so there's different links for web pages. So each of the observatories, NuSTAR, NICER, Chandra, XMM, they have a cycle once a year where you can apply. You can see, so we just went through the NuSTAR, that was in January, so the next one is next year. September is the NICER one, 23. And then we have the Chandra is coming up March 15. So if you want to do a Chandra proposal, you can still do that in a month's time. And then we've got XMM in October 23. So all of those will have So if you go to those pages, there'll be lots of instructions of what you need to do. So before you do that, before you start the proposal, just go read everything there. So I talked a little bit about what's a time allocation committee. So these are the people who then select the proposals. So before COVID, they were pretty much all in person. So something like 100 people or more converged on a hotel and were locked in rooms, and then they had 3 days or 2 days to talk through all the proposals, and then they picked them. It's all virtual now. So you'll have a number of panels. So when this goes on, you'll have a number of panels. There'll be 5 to 7 people in each topical panel. They will be reviewing 30 to 60 proposals. And so you can already see 30 to 60 proposals, they'll probably spend something like 10 to 20 minutes on your proposal. That's about all the time they have. They'll get them something like 4 weeks before the proposal, so they have to kind of distribute them out across, if you want to be ahead of it and not read it on the plane on the way to the proposal, which some do, you'll have to distribute them throughout time. So it means over 4 weeks, you'll be reading 60 proposals, and it's impossible to remember all of them. So you'll do notes and all of that. But then once you come to the meeting, there will be discussions of the proposal. So each proposal has a primary and secondary reviewer, plus whoever else is in the room. So you'll have one person who's your champion, and then you'll have a backup. If your champion loves your proposal, you have a pretty good chance they'll argue well for your proposal. If your champion does not like your proposal, you're in trouble. It can be very hard to recover a proposal from a negative primary reviewer. So, yeah. But sometimes don't just get discouraged. It could just be your proposal doesn't necessarily have to be badly written. You just have to be unlucky and get a person who just didn't like your science. That happens, unfortunately. So the proposals get ranked initially, which means they're going to throw out 50% of the proposals right off the bat. They're never going to be discussed. Then they'll discuss the final proposals, and then they'll rank them. So that's what happens in the proposal review. So you can tell it's really important that you capture them, that you right away are very clear what you want to do, and then you capture their interest and imagination. Okay, so dual anonymous reviews is what NASA has now. A dual anonymous review means that no personal information goes into the proposal. The proposer, you can't say who you are, you can't say who's on your team. It's completely anonymous, and the person reading it, the dual anonymous is that you don't know who reviewed your proposal. So they don't know who you are, you don't know who they are. All you see in the end is a score and a comments on how well your proposal did. The reason they implemented this dual anonymous review, and all of the NASA missions has it now, the reason they did that is because there was a gender imbalance. There was a tendency for male proposers to get more proposals accepted than female. And there was also a career balance. There was a tendency that established astrophysicists, older established astrophysicists got more because they were known, they had their name behind them, that they got a biased selection because they were known and they had written lots of papers. Now, by making it anonymous, you can't tell whether it's a graduate student writing it or a senior faculty scientist. You may be able to read between the lines, but in principle, you cannot. And that has helped greatly. So the gender imbalance, they're not really seeing a much difference there, but they can really see that since the dual anonymous review, a lot of early career scientists and students are getting their proposals accepted. So that really helped that. There are other biases as well, personal opinions on if your rival wrote a proposal and you're on that panel, you might have an internal bias, even though you don't want to have that. You might have an internal bias that opposes whatever they're suggesting. So there's a set of guidelines for dual anonymous review. They're online. You should just read them. They're very good. None of the ESA reviews, as far as I know, are dual anonymous. So just be careful. You cannot take an XMM proposal and throw it as is, because that's what people used to do. They take an XMM proposal, throw it to New Star, or take a New Star proposal, throw it to XMM. You have to be careful about this because one is due anonymous, the other one is not. So just be careful about that. So we talked a little bit about narrative. Now, proposal outline is this is a standard way to do a proposal outline. So these are just really sections in the proposal. You'll have an abstract, which has to be concise. It has to capture everything that you want to do. Why do you want to do it? How are you going to do it? And what do you plan to get out of it? Then you have to the introduction, which is the important one, which is where you capture, where you create interest. You can, in this introduction, that's where you can use some personal voice instead of being very scientific in your writing. I'd say in the introduction, you can become a little personal. You can throw around words you would usually put in papers, for example, and kind of create some enthusiasm for the idea you're trying to propose. Then you go into the scientific justification, and here you again have to be really scientific. You have to be really precise. You have to present your science question, your hypothesis, your predictions, and then you have the feasibility of what you want to do and the observing plan. So now you want to show that your proposed observing plan is sufficient to give you the data in your predictions and can disprove your hypothesis. And then you have a conclusion, which is just a summary of the objective and the plan. So these are the conclusion and the abstract are pretty much when you are at a review and you want to quickly see, people will go and quickly glance through your proposal. If they should be able to read the abstract and the conclusion and understand what's actually in your proposal, and then your details are in the main text. Okay, so example, what are observing plans different kinds of observing plans for a proposal? So there is, you have one object and you want to observe it for XX kiloseconds. That's a very, very, very typical one. That's probably 80% of them are that type. Then you can have one object for multiple exposures of XX kiloseconds over YY days, weeks, or months. So that's another type. For example, you may have an AGN and you want to observe it 3 times, 20 kiloseconds a week in between. Then you've got target of opportunity, that's the TOO. So you have a list of objectives, you have a list of objects, your favorite black hole binaries that are quiescent, and you have a trigger criteria that says if any of these go into outbursts, I want to be observing them with an observing plan that either looks like 1 or 2. And then the final kind of type of observing plan you'll have is you have a list of objects, which could be very obscured AGN. You have 10 of them in your list and you want to observe each of them for 20 kiloseconds. And so your total exposure time is 10 times the 20 kiloseconds. So you would have 200 kiloseconds of exposure time proposed. Okay, so let's get into the science justification. This is where you have to prove that what you propose for, that you will get, that your observation that you propose for will actually answer the question that you pose in your proposal. And so what you have to do is there will be available response files. So this is the ARF, the ancillary response function, the RMF, the response matrix file. Those will be made available when you go to the proposal sites. You can take those and you can then simulate your spectrum to see that what you are proposing and what you predict you will get out of your observation, you'll be able to measure what you have in your objective. So there's a couple of different ways to do this. There's actually some online ones on HereSoc that you can use. There's WebPins and there's WebSpec for simple spectra. WebPIMS gives you count rates and WebSpec gives you spectra for very simple models. And if you need something that's more complicated, you have to go to XSpec and do fake it. And I'll just give you a couple things of that. But before I go to that, here's some more tips I just want to run past you. So I said a review is going to spend maybe 10 to 20 minutes on your proposal at most. They're not, so that's going to happen over several weeks. So what you got to do is you got to make the work for them as easy as possible. So avoid long, complicated sentences. You know, break down into shorter and clearer sentences. As a reviewer, I'll appreciate not having to reread a complicated sentence 5 times in order to understand what it is and just have a simple one. Even if it feels a little stupid and it feels like the text doesn't flow, that's better than having to make me read your sentence 5 times. Use references, but don't rely on them. And this may be a little strange, but provide a short summary. If you use a reference, provide a short summary of what's in the reference, because 90% of the times the reviewers won't have time to go actually check up on that reference. So just very short summary. If it's an important reference, then just make a little summary of what's in there. Make it easy for the reviewer to follow along. Don't make them do any investigation on their own. Don't send them off to a web page and, you know, you can check for yourself, blah, blah, or do any calculations. Please do all the calculations for them in the text and make it clear how you did the calculation so that they won't have to do that on their own. Okay, so WebSpec is an online thing. It allows you to, you can see very simple models, and the drop-down menu up there will have all the NASA observatories. Actually, I think it has XMM2 in there. So you can go there and you can then put in your model, and you can get out a spectrum that you can then download, and you can then do fitting in XSpec with it. Then there is WebPins, which just gives you a count rate. Count rate is often something that they require to give you to the proposal. They say, okay, what's your expected count rate? You have to then take a flux that you have from your model, throw it into WebPins, get a count rate, and then you have to write that in a header somewhere in the proposal. So XSpec is, you can with XSpec do some, if you have the response files of the instrument, you can simulate your model. So what you do is you first put the model into XSpec, the same way you've been doing it when you're doing fitting, and then you use the command called fake it, and then the background file name in there. Then it'll come up with some dialogue, and you enter your R file, your RMF file, and your exposure time, and then it'll fake it your spectrum, and then you can fit your model, and you can do error estimates on your parameters that you're interested in, and that you can then put into your proposal. So very careful when you use when you use fake it, do not run it multiple times in a row. Always clear the data before running it again, because it does weird things. It runs on every spectrum that's in there, it's going to run fake it on top of it, and it gets really weird. Okay, so there's an exercise for you. So for your project you already have, you should write down science goal, a science question, a hypothesis, a prediction, and an objective. So you should write that as an abstract, write it as if you are applying for a talk, and then you can realize you can use that pretty much as your introduction and the final presentation. If you write that cleanly down, that will pretty much be your introduction when you give the final presentation. So with that, I want to maybe actually hand over the microphone to some of these guys if they have something to add about proposal writing.
Okay, that was an awesome introduction to proposal writing, so it's hard to know what to add to that. But one thing I would say is that Kristin talked a lot about the contents of the proposals. The other thing I think it is worth thinking about is the formatting of your proposal on a page. Many of us, when we're reading 60, 70 proposals in the space of a couple of weeks, we don't want to have to print them out. So we're going to be reading them on a computer screen, on an iPad, something like that. So really think about making your formatting as clear as possible. I have seen so many proposers, and I apologize to anyone in the room who does this, but the one thing that really annoys me in reading proposals is when people format them in 2 columns, like a paper, because it makes it much more difficult to quickly scan down the proposal on a screen when I've only got 10 minutes to look through it. So nice clear fonts, single column, clear figures, big text on those figures so that I know exactly what you're trying to get across. I can see exactly what your message is, and I can absorb what you're trying to tell me without having to struggle with the formatting, struggle with the figures.
I just wanted to add something. This was a great presentation. I just finished reading a lot of very long proposals. I don't tell you what for, not observations. It is true that you have 10, 15 minutes to read the proposals. So aim at that, but consider 1 minute. If the person had 1 minute, would he or she be able to get the content of the proposal? I think this is a very important test. So you just go through like this for 1 minute, and you have to get an idea. This is a good test to see whether you're in the right direction. And then, of course, it will take more than 1 minute to read it, but it gives a flash.
This doesn't work either, does it? Does it? It doesn't work. Yeah, I actually forgot to say this. Highlight important statements throughout the proposal, but don't overdo it. Don't do too many. Oh, there's a lot of here. It's okay. So anyone else? Javier, you wanted to do something too?
Yeah. Thank you, Kristin. I've learned a lot through your presentation, so I've made a list of the 8 mistakes I make myself. But I wanted to add something which is crucially important for any proposals on observability. So let me go there, otherwise your neck will be strained. There are two questions, fundamental questions that any reviewer will be asking in reading your proposal. First is why me? So why this observatory as opposed to others? So you have to make absolutely clear in an XMM proposal why you want to use XMM as opposed to Chandra. By the time you are in short, you already know the standard answer. XMM is a larger effective area for spectroscopy and for moderate imaging spectroscopy, or you want to solve the best of the topics event, which now we can achieve that you probably not discussed about. You are familiar with Chandra data, you are probably familiar with the concept of contamination that is killing the effective area of Chandra below 1 kilo. So when you write the proposal, clearly make it explicit why you believe your proposal shall be done with XMM as opposed to Chandra, as opposed to NICER, as opposed to. And the second, more important question that any reviewer is going to ask is, why are you asking a certain exposure time? And therefore, it has to be clear to you why you are asking a certain exposure time. It's not the same, it's not the same chances of success. If you ask 10 kiloseconds, 100 kiloseconds, or 1 megasecond, and you may guess, you will get very long observations only if your science is fully compatible. So one of the most difficult exercises in writing a proposal is calculating a correct exposure time. And actually, there is a correct. A correct exposure time is a minimum exposure time plus margin that allows you to achieve the science. If you ask less, proposal will be rejected altogether. You know, reviewers are clever. If you ask 10 kiloseconds for a science that needs 100, reviewers do not need to make it longer proposal. They realize immediately in your proposal was perfectly enough. If you ask 1 megasecond for science can be done in 1 kilosecond, your reviewers are clever. Most likely, they will take your proposal because if you don't put the right number, the right exposure time, you convey the impression that you have not thought sufficiently long on the proposal. So what is the correct exposure time? I repeat, it's the minimum exposure time that allows to achieve your scientific objectives, or to answer your scientific. And, you know, The way most of a proposal deal with that is, I'm asking for 100 kiloseconds. Here you are, a wonderful 100 kiloseconds spectrum, and you see I can make my science. Now, many proposals do that. I think this is the wrong approach. The wrong approach, which is followed by a good fraction of proposals, but not the majority, is do several simulations with several exposure times. You want to measure a certain plasma diagnostic by emission line. Imagine that you want to measure the ratio of two emission lines to measure a certain temperature or other or density. So make simulations with different exposure time, 10, 20, 50, 100, 200 kiloseconds. Measure this diagnostic ratio among lines for each of your spectrum. Calculate the accuracy of your measurement, and show how the accuracy improves with better exposure time. At some point, you will reach a minimum exposure time, beyond which your accuracy is already overcome your threshold. Of course, you have to tell in the proposal, I want to measure the ratio of this line at an accuracy of 5%. At some point, you will reach 5%. At some exposure time, you reach 5%. If you ask for more, you reach 3, 2, 1% accuracy. But you know, you are not asking for 1, 3 to 1%. You are asking for 5. So the exposure time when you achieve 5 is the correct exposure time. And add in XMM Newton, especially some margin, because in XMM Newton you may have high background flares. By the time who is working with XML, you know what it is. So add also a certain 20–30% margin to achieve, to take into account the possibility that your observation will be affected by high flares. And that is your correct number. Minimum exposure time to achieve the statistical accuracy you need, plus 30%. If you do the job this way, first of all, you are asking for the right amount of time for your science, which is good, but you also show the reviewers that you have done your job properly, and your proposal will not be rejected for bad feasibility. So the first advice is important. The second advice is, in my view, crucial for your chances of success. Who is next?
I think most of the important things have been covered, but as these folks were talking, I was remembering things that I struggled with when I was writing proposals. So I figured I'd give you some examples of failure. My first example of failure, it was my first proposal, my first observing proposal. I decided as a student, I wanna write a proposal. I wanna take an observation myself. I never done it before. I worked really hard. I found a source that I thought was very interesting. It was an X-ray binary. And I read a bunch of papers. I spent 2 weeks working exclusively on it. The night before, I was working until very late with my mentor at the time. And we were at the office and I was almost done. And then he comes to my office at 10 p.m. and says, I don't think you can send this proposal. I say, why not? The source is not visible in X-rays anymore. It's a transient. Did you ever check for that? And obviously I didn't. So all that work was for nothing. It was a transient. It had been seen in hours. And then at the time, it was not seen anymore, right? So that proposal would have been sent directly to the trash bin, as Matteo said, because it was completely unfeasible. And even worse, that was before the double blind. So I would have been, you know,
ridiculed,
ashamed, yeah, publicly. So there are things in writing proposals that a lot of people don't tell you that you need to check. That is, especially the first time you write a proposal, an observing proposal, for example, there is a lot more work that goes into it in addition to writing the science. So I've seen this very often with my students and postdocs. They spend all their energy and time in writing the science proposal, which is obviously the most important part. But then they get to T minus 15 minutes of submission and they're like, okay, how do I submit this? Well, it's not as simple as sending an email. You have to go and fill up a form. There is a whole bunch of questions. Some of them are quite technical. And then you realize, oh my gosh, I don't have time. And I've seen people failing submitting their proposal on time because of small, stupid things like that, right? So make sure you read, Kristin talked about reading the documentation. Make sure you don't miss on the easiest stuff, which is choosing the wrong format, choosing the wrong font, going over the page limits, using less pages that you are allowed to. So I'm observing proposals that give you 4 pages, but then if you're asking for coordinated observation between 2 different observatories, they give you 5. If you write a proposal like that and you only use 4 pages, it might sound appealing for the reviewers because, yeah, as a reviewer, you have a lot of work, but I've seen proposals being negatively seen because it's like, well, they have 5 pages to write this. They didn't explain everything as they could, and they have a whole extra page that they didn't use. So these are small things that people normally won't tell you. They're not written anywhere, but please be mindful about that. I forgot my other bad experience. Well, that had been bad experience even for me. Sometimes I forget about certain small things, and I've been caught in the last minute running for taking care of that. Kristin and the rest talk a lot about the point of view of the reviewer. This is something you're not going to really understand right now. I don't think you can understand what it is to feel on the other side of the fence. So my advice is, first of all, don't feel discouraged. This is also a bit of a game, numbers game. Like, you need to write many proposals to get better at it. And sometimes you write an excellent proposal and it just doesn't get picked. You know, not everything is a learning lesson. Sometimes you just fail and there's nothing you can do about it. Because the oversubscription can be quite high in some of these facilities. It could be four times or 6 times more proposals at the time that is allowed. So if you write a proposal and you get rejected, don't take it as an absolute term saying, well, this proposal got rejected because I wrote it terribly wrong. It doesn't necessarily work like that. Panels are different and we're all humans. So different panels will review the same proposal differently. Another experience I had, I wrote one proposal for Chandra theory. This is a small part of the Chandra observatories that allocates a very small amount of money for developing theory to work on Chandra observations. So it's quite competitive because there's just not that much money available. The first time I wrote it, I worked really hard on this proposal. I thought it was great. I thought it was the best proposal I could write on that subject. And it was very pertinent to the observatory. I got a terrible review. I got one of the lowest grades I ever gotten. Next year, I tried again. I look at the proposal. I kept thinking, there's nothing I want to change here. This is a beautiful proposal. I like it. I just submitted it exactly the same and got a better review. I submitted the same proposal 4 years in a row. The last time was finally picked. The grade was excellent. I didn't change a single word. It was just a different panel. And they're so competitive that when the situation is like that, the reviewers, it turns out that your job as a reviewer is essentially trying to find any hole that you can find in the proposals to kill them, because you just don't have enough time or money available and you need to pick the best of the best. So that's the advice. Just don't be discouraged. Just keep trying. And it is an art, as Kristin wrote in one of the slides. Writing a good proposal becomes an art at some point, and you can get good at it by just doing it a lot. That's it.
Do we want to do questions or do we want to do it straight away?
The record I think I've seen for proposals being accepted upon resubmission. 8 years in a row.
I'll start this one.
And last thing I wanted to add, I work on many sorts of integrity tests. I failed a few times to that proposal, and I keep checking feasibility quite as carefully as I should have. And I get to the proposal and realize, oh, I'm going to ask for 500 milliseconds or something. And
Do we want to do quick questions before you go walking through? Okay, so let's do questions from,
Hi, thank you for all your input. The question is, if you were to submit a very strong project that might have a great success rate, but you make a mistake with maybe exposure time, does the reviewers just chuck that out, or will they give you feedback, which then you can?
they will give you
Okay.
feedback. A good reviewers, they will say, okay, let's say, let's say your exposure time was, as Matteo said, it was borderline. You asked for 150 and you probably needed 200. So you put down 150 and it raised questions in the reviewer's mind. So then they would probably the feedback would be, we do not think that this can be done in 150 kiloseconds time. And they might, depending on what it is you're looking for, an iron line, a cutoff energy, whatever, they might say something towards that effect. But you will, if they rejected your proposal because the exposure time was insufficient, it will say so, pretty much.
And then will you have the opportunity then in the next call?
Yes,
to
so the
submit that?
year later, the slate is wiped clean, completely clean, you start over again. And because it is most likely a different batch of reviewers, people don't tend to do the same review 2 times in a row and 2 years in a row. There'll be a little bit of time because it's a lot of effort. So the slate is wiped clean, you go in another round. None of what you did before is remembered.
Yeah, thank you, Kristin, for a very insightful talk. I have a kind of like a few questions, but when you spoke about the do's and don'ts regarding English words to use, do you guys factor in, like, if someone's used a word on the list of the ones you said people should not use, you factor in like the quality of the science, or do you just like, I don't like this word, it's kind of like cliche, and then you just throw away the proposal?
So those do's and don'ts you're talking about, don't say, I want to understand, I want to measure, that's the one you meant.
Yeah.
So those are very subjective. When you write them, most don't go like, oh, he wrote characterize or he wrote measure. They'll have a feeling that this is too vague. You know, when you say, I want to understand how this black hole, the growth of this black hole. It's very vague. You know, how do you want to understand it? Do you want to understand it in the accretion, how it accretes? Do you want to understand how it got its spin? So it will just trigger a thought going like, well, this is a little vague. I don't really know what it is you want to do. So those do's and don'ts is to make it clear when you write those sentences, that when a person reads it, that it's clear to them what it is you want to do and not very vague. Because sometimes you have proposals, don't really know what they do, and they hide behind vague words. And a good proposal will pick up on that. You're not being clear about what you really want to do. You just want to observe this spectrum. Don't really know what you want to do. You just want to observe this source. You have to observe it for a reason, and that has to be in your writing why you want it to observe it.
Okay, yeah, I get that, but I was also thinking from the perspective of like non-native English speakers who
Non-native speakers, yes.
can probably articulate their words properly.
That,
is that factored in?
yeah. So we, as a proposal, you do pick up on that. You can kind of see, and most people will be sympathetic towards that and make it clear that, oh, these are not native English speakers, so we have to read between the lines. And this is where, if you're a non-native speaker, be careful about long sentences. It's better to write short sentences, be very clear with each sentence, and it may not flow as nicely as a native speaker, but it's much better to have clear short sentences than one big garbled mess.
So there is an allowance.
Yeah,
for people to-
absolutely. You will be able to tell. You can be able to, we have a lot of Japanese who have very hard time writing proposals, and And you can read it and then you kind of be, what do you call, sympathetic towards it, or you do.
Yeah, but the thing is that the way you're framing the question leads me to believe that maybe you understanding that this is sort of a set of rules. And I don't think that's the case. I think this is derived from people that have thought about the process and studied these things. And they think that the way reviewers perceive language is going to work like that. So it's not like the reviewers are instructed. If you read a proposal
No.
that these words,
Not at all.
No, it's not like that. This is kind of like a indirect way, like a subliminal message that you send to the reviewers. So it's kind of like good practices when writing. Try to avoid this, try to follow more this sort of language. The problem with more native speakers, like in my case, is it's hard to avoid because we're talking about human beings. So a very beautiful recent proposal with perfect English is always going to have sort of an edge and advantage over it. So your best bet is to be, as Kristin said, try to be simple. Don't try to be clever with your English when maybe you don't have that dexterity to do so. And another thing is just try to go to collaborators that are good in English, and ask them to help you. That is also very common.
Yeah. Carlos, or comment.
Yeah, sorry. Just a comment because of the conference is organized by examining the certificates, so I was not paying attention to focus. Sorry. There is a conference every year, every third year, there is a general conference called X-Ray Universe, and every year there is one small conference dedicated to one specific item. This year is the X-Ray Universe General Conference in Athens in July. Last year was on black hole accretion. The year before it was a high energy view of exoplanets and so on. You can find them always on the X-Ray Universe pages. And if you want to go to one of these conferences and you get a talk or so, please, in your talk, mention that you have participated in one of the course capacity building workshops. This will help for our funding in the future of these events. Yeah.
Yeah, and I also want to say, actually, we do a lot of effort in the US to make sure that we have students give talks. So when you submit and it asks for your, what level are you at, please submit that, because when they PIP abstracts, they will look at that, and you may have a higher probability of being picked for being a student. Right behind you.
Yes, my concern is about this review process. I'm wondering whether the review process is only meant to either accept or reject proposal. Otherwise, I would have loved it to be in such a way that it gives the proposer a chance of, improving on the proposal and resubmit things.
So they always give comments back to you. You'll have to read them. Sometimes they make sense, sometimes they do not make sense. As Javier was saying, sometimes they were clearly not reading it, or they were distracted, or they didn't want to pick this. And sometimes it makes absolute sense. You go, oh, I forgot this. I was not clear about that. So when you get a comment back, look at it and see, does it make sense? And again, you're dealing with a panel. There's 7 people in there, or 5 to 7 people in there. There's going to be one person who will completely and read your proposal. The others are supposed to read your proposal. There's a secondary who's supposed to read your proposal too, and they mostly do that too. But the primary, if he does not like or she does not like your proposal and they argue really hard for it, there tends to be, it tends to the others not to go like, okay, well, he knows what he talks about. Okay, then they'll influence their grading. It shouldn't be like that. It's what happens. If you have a primary who's very excited about your proposal and they are able to sway everyone, you can have a good. So it's very subjective, even though we have the dual anonymous, it's still people. And however, whichever mood they were in when they read it, is going to influence a bit their opinion. So you're trying to remove as many things in your proposal that might tip it towards negative, make it easy for them, make it easy to read, make it clear, so that they don't have that excuse. Yeah. Okay.
So may I add one, and then I can take last question from her. So I have seen a couple of proposals for astrosat and also for optical observatories. The applicants try to use the influence of their supervisors or the group with which they are coordinating or collaborating. So don't do that. If it comes to a person like me, I really get annoyed. You are not talking about science, but you are talking about what your group is doing. That will not get any positive score unless you define your goals properly, or why you want this much time and whether your time is properly justified. And as Kristin mentioned, there are many tools. You can, for all the observatories, you can go to the observatory website and find, and they will tell you how to calculate expected number of counts for your source. Or there are tools, for example, visibility calculators. So you can use all those to make a proper estimation rather than just blabbering some numbers from your mind. And yeah, that's it.
Yeah, hi. So I have a little experience with the AstroSat proposal. So based on that, so there is called the partial allocation instead of full allocation sometimes. So how did they decide? I mean, what are the criteria for partial allocation? Why don't they just reject it? Or
I didn't talk about the priorities. Okay, so all observatories have somewhat of a priority system. So in the case of, now I'm taking New Star, we have A, B, and C. So A targets will absolutely be observed. B targets will be pretty much observed too, most of them, but some of them, they can't be promised. And the reason for that is you have these TOOs, so target of opportunities, which are if a source goes into outburst, then you will observe it. But there's a probability of that. If it doesn't go into outburst, then you never observe it. So there's a time that's been allocated for all of the TOOs that were selected. So let's say let's say about 1 megasecond of time has been allocated to targeted opportunities. Now only half of those got triggered. We expect only half. There's a trigger probability to all of that. So we expect only half of them to be triggered, but we have to allocate the full time for them. But we expect only half to be triggered in reality, but we have to do the full. And then that means that there is 500 kiloseconds of excess. So that's where we have the B targets, which means we'll take as many B targets as we can. If we don't do as many TOOs, we'll just take B targets and throw them in until we get. So if we use up all the B targets, there's the C targets. So C targets, in the case of New Star, no promise they'll be observed. You won't get any funding for them. So they're really the last bit of fillers. When we run out of A and B targets, we have C targets. So and all observatories have somewhat of the same layout. They may call them different things, but it's simply because you have to fill up, you have maybe 5-6 megaseconds of time in an observatory in a year. You have to fill that up, and you do that first with A targets, but then you've got a chunk of time that's TOO, and it may be the full thing, it may be none of it. So that's why you have these unallocated time where they can't promise that they'll observe it. Does that answer it?
Yeah.
Science, it's just science. The ranking, so your B targets, so the A targets is the highest ranked plus TOOs, and then you've got the lower ranks, then they turn into Bs, and then they turn into Cs.
And I can add a couple of comments from what we've done on both XMM Newton and New Start panels before, this idea of partial allocation. So as a panel, the mission directors will give us an allocation of time that we're allowed to allocate to all the proposals in our panel. What we'll do is we'll discuss all the proposals, we'll come up with a rank list, and then we'll work down that rank list, allocating proposals, and then that will take away the time that we have available. And where we often find ourselves with partial allocations is when we get close to the end of the time we've got available. And what we might end up with is we allocate the top bunch of our proposals, and then maybe we've got 200 kiloseconds left in the bank, but then the next proposal in the rank wants 400 kiloseconds. And then we have to ask the question of, should we give the remaining time to that proposal? So then what we'll do is we'll look at that proposal and we'll decide if it makes sense to allocate it. So in this case, so say that 400 kiloseconds was they wanted to do a really deep observation of an AGN to look at soft X-ray emission lines. And from the science justification, they show that they need the 400 kiloseconds. So in that time, in that sense, we probably wouldn't give them 200 because that they haven't demonstrated they can use 200. But where we often do partial allocations is if a proposal is looking at a sample of objects, maybe they want to look at 5 objects for 100 kiloseconds each, then we might give them 2 of the objects in the rank. And in this case, it's actually really helpful. If you want to observe a sample of objects, it's really helpful for the panel. If there's a rank order, that you sort of have ones that are your top priority and then ones that are lower priority. If you make that clear in your proposal, then that can be helpful. And we'll do a couple of your objects so you can sort of get your sample started, and then you can apply again next year to complete the rest of the proposal.
So since EC asked about AstroSat, so I wanted to add in that direction as well. So as you mentioned this, if you are asking for number of targets, then generally AstroSat time allocation committee approves only 1 or 2 targets. They want to know like whether you can start your serving your objectives, at least you should get it started. And then if you have, I mean, many times in AstroSat proposals, we have seen like the time requested is not properly justified. People try to put over exposure, and this is why they are asked for, okay, you are getting only 70% of your requested time. And still the AstroSat time allocation committee is not harsh, very harsh. Yeah. Yeah, one last question, then we can go to Jeremy's presentation.
Sorry, Jeremy. What happens with unexpected events like multi-messenger events? You have a neutron-neutron merger.
Oh, so this is a bit of a political controversial topic, and different observatories have gone at it differently. When it first happened, when GW 170817 happened, it was, so most of the observatories use what's called DDT, Director's Discretionary Time. That means we did it, the observatories, the teams themselves went and observed, try to do the follow-up on observing the source. So that was when that happened. And then there was a whole discussion of whether we should allow multi-messenger events to go through attack, or whether it should be DDT time, because the instrument people themselves knew better how to best use the observatories to follow up events. And so each different observatory had different discussions about that. In the end, it's now all gone towards that. It is all actually going through the same proposals. They go through the tax. And so people will make suggestions for how to follow up multi-messenger events. So there's a TOO time of target of opportunity proposal, probably 3 to 4 in each of the different observatories that has a plan for following up gravitational events. So it's back to the proposers, and the observatories are not doing anything special. Although, you know, the PIs, if no one does anything, then the directors of discretionary time, they may choose to step in and do something about it. But it's all going through the tax now. So if you have an idea, you should just go through the tax. I think that's it.
Yeah, I'm taking liberty. So many of the observatories do have an option called anticipated TO. So many of these coordinate, if you know that you want to coordinate with so many observatories or you want to follow GW event, then you can go through that anticipated TO program. Yeah, I don't know
Yeah,
what.
so let me add something to that. So there's this TOO, everyone has it, or DDT. And let's say there's an event happens, there's something goes in outburst and you want to observe it. And you didn't have a proposal in, but you want to observe it now and you submit a TOO, say, I want to observe this now. If there is already a TOO that was approved in the cycle, it will have precedence and it got triggered. So if someone says, I want to, they had a proposal in there, it was accepted and they trigger it, you're not getting it, then their proposal takes precedent over that. If no one triggers on and you're the only one that submitted it, that submitted a TO at the same time, then, and it gets accepted. So let's say you, and this is a quick turnaround. Let's say you propose in a day and then you'll get your answer back in 1 or 2 days. It says whether or not the observatory will go and follow it up. So you can do that, but just know that if someone else has an accepted proposal, that will take precedence if they triggered it.
So I think we can take some of these questions after Jeremy's presentation. He wants to talk about, I think you can also extend both the questions up to 11:15. Okay.
Yeah, so I just wanted to briefly show a few tools I frequently use when writing proposals, but they're also generally useful kind of across all wavelengths even. So I think it's useful to show some of them. The main one is the one I talked about a little earlier last week. It's called ESA Sky. And it's a pretty powerful tool. So when you load ESA Sky, it will just put you somewhere. It's fine, I can just use this. Thanks. Put you somewhere random in the sky. And I think it typically selects optical and DSS, but it has, as you can see here, a large number of different optical observatories. So for instance, we can swap to pan-stars and get a nicer image of this galaxy. And it also has many wavelengths. So it has everything from gamma ray, where you can actually plot the whole Fermi sky, which you see here. The whole way down to radio. And you can also build these different layers in. So you also have, like, for instance, near infrared, if people are familiar with 2MASS. And the way you can use it is, so let's say, for instance, let's close these. You want to look at hard X-ray sources that maybe haven't been observed in soft X-rays yet. You can load in, for instance, this is a Swift bat. Sometimes it takes seconds to load. Oh, yeah, sure. Okay, so here it's loaded in the entire Swift bat hard X-ray sky. So it pulls this data directly from the archives. And then you have options here. So up top, I'm just going to focus on the first two because those are the main two that I use. There's one that shows you the actual lists of observations that have occurred through any observatory, and the other is a catalog tool. So this has a ton of catalogs across the entire, across all wavelengths, essentially. The one I'm going to pull up just for an example is called Integral. So you can select down here the range of wavelengths you want to look in. So let's say we want to look at X-rays. We can pull in the hard X-ray catalog from Integral. It'll take a minute to load. But it'll basically plop all of these squares down on all the known sources. So Integral is slightly different than Swift, but I don't know that Swift's hard X-ray catalogs in ESA Sky. But you can basically then go and see all these sources and what they are. If you click on one, it highlights it in the table. So for instance, this is a Seifert AGN galaxy. So you can also use all the columns here. So for instance, let's say we want to filter on only unidentified sources. So now here's a list of integral sources that we still don't know what they are because this is the class column. So let's say you've done that. And now you want to see what sources have X-ray observations at shorter wavelengths. So Chandra XMM. We can swap down here to XMM and it will take a minute to load. The danger of doing live demos. Sorry. Yeah. It looks like it dropped for. Mm. It's back, I think, hopefully. Is this guest? You can basically see all of the XMM Newton observations. They're plotted here that cover different fields. So we can go, for instance, to this one. And you can see that there's a bright soft X-ray source here. You can click on this again, and it'll bring it up in the panel down here. And you can basically use that to look at what the source is, the coordinates, and go look up all the information you want to know about it. And you can also then look for sources that are not observed. So for instance, this one doesn't have any XMM Newton observations. Looks like it's potentially a high mass X-ray binary candidate, but maybe it would make a good target for a proposal. Okay, so this is kind of how I typically use it for proposals or searching for sources, but it has a little more power that I'll just show off really quickly with this cluster. So this is a globular cluster. As you can see in optical here, get a little bit nicer image in pan stars. So this cluster has also been observed with HST. So if you want to access HST data quickly on the fly, you can do that here. It pulls it again straight from the archive, and you can see Hubble's view of the cluster. But another big thing they've been doing lately is actually looking at the archives of James Webb. And so if you click this button up here, it shows which observatories have observed this field. See, Webb is here, and below it will load all of the Webb observations. And it also overplots the field of view of Webb and how it was oriented. So this sometimes takes a little long, but if you click here, it will also actually bring in the data and it'll show an image of the Webb field of view over this cluster. What you see here. So this is basically the James Webb observation of this globular cluster, which is pretty awesome that you can kind of ignore all of the data archives and just get it straight from ESA Sky. Furthermore, if you want to open it in DS9, you can click this download button and it'll directly download the data and you can play around with it in DS9 and do whatever you want to do with it. Okay, one last thing. There's also a really nice tool through XMM from their source catalogs. So I already talked a bit about the 4XMM source catalog. So they have these tools where basically, let's say you find an X-ray source that you're interested in looking at the spectrum. And let's say you're looking at, I don't know, 100 different sources or something where you don't want to download the data and extract the spectrum every time. You can put in your coordinates and it will load your sources. So they're ordered from how far offset they are from the position you put in. So let's take the closest one. It will bring up all of the information related to the source across all the different observations. So previously it showed that there were 8 detections. They're all showed here. This is an image of the source that's just directly plotted in your browser. So they also show the off-axis angle. So let's take the one where the source was actually targeted. And you can basically fit the spectrum of sources kind of directly in your browser just to get an idea. So I wouldn't use this for actual science in like a paper, but for doing quick analysis and trying to understand a source spectrum, it's very fast. So I happen to know this source has some contamination due to a star that's not resolved by XMM. That doesn't have the angular resolution to resolve it. So we're going to chop out the below 2 kV of the spectrum. We're just going to fit it with an absorbed power law. And there you go, basically fits the spectrum and then provides all your fit statistics and best fit parameters down here. So yeah, I just wanted to give a brief overview of these are kind of tools I frequently use when searching for sources that I want to observe and write proposals for. So thanks.
Questions, comments? And you can ask questions about proposals as well.
Hello. So for example, you want to write a proposal where you want some orbital period to see, right? Say for example, you want say orbital phase, like you want to observe the egress part of the orbit, but I got a return review that says, please justify the time. Like, so like what to do then?
Okay, so first you have to make sure that you click a button. You know, it's different for different observatories, but they always have time constraint. So your observatory is definitely time constrained. So I don't know if you did that. Number one. Did you put in, so first on you have to say it's time constraint, and then you have to say very clearly, why is it time constrained? And if they say that you didn't justify it well enough, that might mean that they missed it. That is possible. If you think that you wrote it clearly enough and they didn't read it, that's possible. But maybe you didn't write it clearly enough, so you may want to relook at it. They didn't understand it. That's the other thing, right? Either they didn't understood what you wrote, or they missed it if you wrote something down, or you didn't do it you didn't do it clearly enough.
So for example, if you want to see certain orbital phases, you just like code that phase and write the time required to observe the entire phase, right? You don't have to further justify because it has been observed before. And
well, your science has to then say, I want to observe this orbital phase because whatever your science question is. So you have to be clear about that's why you want this particular part of the orbital period.
Yeah, sure. Thanks.
So if you did that and it just wasn't clear, that might be why it triggered such a comment.
We have 10, 15 minutes. Maybe 10-15 minutes to have discussions about proposals.
Yeah, if you have proposals and you have you've gotten if you want us to look at your proposals you've submitted and you've got reports back, comments back, we're happy to sit down and read them with you. Well, the other question is if we have some successful proposals, we could share with them. If any of you guys have some you're willing to share with them, we could do that too.
Do the accepted proposals, are the abstracts made public?
Yes, they are. Huh? Yeah, no, just the abstracts.
Okay. And like, can one go back to previous years and see all the abstracts for accepted proposals for a certain instrument?
Depends on how they have organized their data. I think you can in NewStar. Okay, yes, yeah.
Okay.
So it's different for different observatories, but you should be able to.
For XMM and Chandra, at least if you go to the data archive and you find an OBS ID that you want to look at, Chandra, there's a button on the left, and XMM, I think it's further down on the right, but you can basically pull up the abstract proposal that was written to get that data set. So say you find a source that you think looks interesting, maybe somebody already observed it for some reason, you can check what that reason was. And it also provides links to papers that were published using that data. So sometimes it's just broad catalog papers, but sometimes somebody writes a specific paper for that data set.
Yeah, you should be aware that there's some work that goes when you've submitted your proposal. There is someone that checks whether this data has already been taken. So there are some situations where people want to observe some source again, and it has already been observed, and the data is already in the archive. No one did anything with it, and you submitted a proposal and you didn't notice. So that happens sometimes. So that goes into the preparation. Know your source is visible. Check if your source has already been observed and it's in an archive. But, you know, for some sources, they go through state changes and then you want to do a new observation. But for a persistent source, an AGN that doesn't do anything at all, and there's already 100 kiloseconds, you ask for another 100 kiloseconds, you have to justify why you need an additional 100 kiloseconds when 100 kiloseconds is already sitting in the archive.
I have a follow-up question. So for DDT or TOO proposals, how does one know if someone has already, you know, their proposal has been accepted? Is that made public?
Yes, so the accepted proposals are made public. So the TOOs are, so they would be called TOOs. DDT is when it's outside of the proposal cycle.
Okay.
So yeah, you can go look. You can also just take, I mean, if something goes off in the sky, yeah, you can go check if someone else did it, but you can also just take a chance and submit a TOO.
Yeah, I know that many of us are spoiled with the kind of practice with the optical observatories and proposals related to optical observatories. Most of the time we get observations as a gift, being part of some group. You just need to write like, yeah, I want to observe blazars for these 3 nights, 4 nights, or GRBs because it's flaring. I am working with this professor and I want to work on that. This kind of spoils us because we actually lose the habit of keeping track of what can be done in this kind of situation using this kind of telescope or instrument or whatnot. We just because you get time just by asking, but this is not the case in any space space-based instrumentation, because it's a highly oversubscribed, it's a highly competitive. So you need to keep track of each and every step of your writing, your justifications. So it's really good opportunity. You have so many people who are directly connected to instruments, directly connected to TAC for different instruments, for example, Kristin, Dan. I mean, you have a nice opportunity to discuss is behind writing a good proposal. So don't hesitate, even if you are not going to write proposals related to X-rays or something, please try to discuss.